We've all seen it, right? AI video generation has just exploded. You type in a single prompt and boom, you get these incredible cinematic scenes that look almost too real. But what happens when we go beyond just making cool-looking videos? What happens when we ask these AIs to actually simulate our physical world? Can they really, truly understand the basic laws of physics? Well, that's the massive question we're digging into today. Okay, so here's our game plan. First up, we're going to tackle what's known as AI's reality problem. Then, we'll introduce a new reality check called R-Bench and see how today's top models actually did on it. After that, we'll get into Robotic, which is a huge new databank designed to solve this very problem. And finally, we'll wrap up with what this all means for the future. Just take a look at this. The prompt was super simple. A single-arm robot closes an oven door. And, the AI kind of gets the gist. But the execution? The robot's arm is, well, it's just floating in pieces. This isn't just a tiny mistake. It's a complete failure to understand that, objects are solid and things are connected. And this right here, this is the core of the problem. And that brings us right into our first section, AI's reality problem. See, there's this massive gap between making a video that looks good and one that's physically correct. For a movie or a meme, who cares, right? But if you're talking about robotics or trying to simulate the real world, physical accuracy isn't just nice to have, it is everything. This slide just lays it all out, crystal clear. On the left, you've got what all the current tests and benchmarks for AI video focus on. Stuff like visual quality, frame clarity, that cinematic feel. But look at the right side. That's what they're totally missing. Did the robot actually do the job? Did its movements make any physical sense? Basic stuff, like did it obey gravity? So, to tackle this head-on, a team of researchers from Peking University and ByteDance basically said, okay, the tools we have are not good enough. We need to build new ones. Tools that could properly measure and eventually help solve this physical reality problem in AI. And this leads us straight to their first major innovation, R-Bench. The best way to think about it is like a brand new, much, much tougher reality check for AI. It's like they built a better ruler, one that's not designed to measure how pretty a video is, but how physically intelligent it is. And yeah, looking at this, you can tell R-Bench isn't just some simple little test. It's this super comprehensive benchmark. We're talking hundreds of really carefully designed test cases across all sorts of different tasks and different kinds of robots. The whole point is to put an AI's grasp of the physical world through a really, really tough workout. So what is this new ruler actually measuring? Well, it boils down to 4 really key things. First, task completion. Plain and simple. Did the robot do what you asked it to do? Second, physical plausibility. Did it follow the basic rules of physics? Third, structural consistency. Did the robot's body stay in one piece, or did it suddenly grow a third arm halfway through? And finally, action completeness. Did it actually follow all the necessary steps to finish the job? Let's just zoom in on physical plausibility for a second, because this one is a huge deal. This metric is specifically designed to catch all those crazy, reality-breaking mistakes we saw earlier. Things like floating parts, objects just phasing through each other, or a robot moving something without even touching it. These are the dead giveaways that an AI just doesn't get how the physical world works. All right, now for the main event, putting these AIs to the test. The researchers took this new, super tough benchmark, and they threw it at some of the world's most advanced video generation models. So how did they hold up? The team tested a whopping 25 different models, a mix of everything from open source to commercial, and even some AIs built specifically for robotics. So the big question is, how did these heavy hitters do when they finally had to take a real physics test? The results were pretty wild. The top spots, yeah, they were taken by big commercial models like WAN 2.6 and Cdance. But look further down the list. Sora V2 Pro, which is famous for its stunningly cinematic videos, landed way down in 17th place. And those models built just for robotics, they were almost at the very bottom. And this points to the first huge insight from this whole thing, something the researchers call the media simulation gap. It turns out models like Sora are absolute geniuses at making things look good. They're built for media, for entertainment. But that skill just doesn't mean they're good at accurately simulating physical tasks. Making a video smooth is not the same thing as making it physically correct.
The second big takeaway, it's all about what they're calling cognitive bottlenecks. Pretty much every single model, even the best ones, really struggled with tasks that needed any kind of logic or reasoning. And they found it was way, way harder for them to generate delicate, fine-grained movements, like a robot hand carefully picking up a tiny screw, than it was to generate big, simple movements, like a robot dog just walking across a room. Now, you're probably wondering, okay, but how do we know this new benchmark is any good? How do we trust it? Well, this number right here is the proof. The researchers found a 0.96 correlation between our bench's automated scores and what human judges thought. I mean, that is an incredibly tight match, and it proves that this new ruler is both effective and very, very accurate. Okay, so our bench is the final exam, but how do you help these AIs study for it? And that brings us to the second half of this amazing solution, Robotic. Because let's be honest, you can't learn physics without the right textbook. To get these models up to speed, the researchers didn't just build a test. They also built the ultimate study guide. Robotic is a massive, incredibly high-quality dataset of robot videos, and it was designed from the ground up to teach AI the fundamental principles of physical interaction. And when I say massive, I am not kidding. Robotic contains 4 million annotated video clips. That's right, 4 million. It is the biggest open-source data site of its kind, built specifically to train this next generation of physically aware AI models. And creating this thing was a serious operation. First, they collected millions of videos from all over. Then, they used AI to filter them for quality. After that, they used another AI to break down and caption every single action in every clip. And for the final touch, they added in physical properties like depth and motion. It's an unbelievably rich resource. So, the million-dollar question, did the new textbook actually work? Oh, yeah, it worked. As you can see on this chart, when the researchers took existing models and trained them a bit more on the new Robotic dataset, their scores on the R-bench test shot way up. The new study guide is a huge success. So when you put this all together, what does it mean? Well, it's paving the way forward. By creating a better way to measure the problem and a better way to teach the solution, these new tools are seriously speeding up the journey to what many are now calling physical AI. So if there's one thing to take away from all this, it's this simple idea. A better ruler, which is our bench, lets us finally accurately measure an AI's physical intelligence. And a better textbook, Robotic, gives us the material to actually teach it. And together, they create this really solid foundation for building the next generation of AI that can actually exist and act in our world. You know, there's a quote from the paper that just absolutely nails it. They say, the field is moving to a new stage, physical AI, where the whole point isn't just to make pretty videos anymore. The new goal is to create models that can truly understand and simulate our complex, messy, physical world. It's a huge shift from just visual flair to actual physical intelligence. And that leaves us with one last, kind of mind-bending thought to chew on. The line between what's a simulation and what's reality, it's getting blurrier every day. If an AI can truly master the physics inside of a video, what's really stopping it from mastering physics in the real world?